Question 12. On what principles do generators operate? Is it electrostatic charge, electromagnetic waves, electrochemical potential, or electromagnetic induction? Now, only one of these should sound familiar at this point, although you'll be learning about all of these eventually. Electrostatic charge relates to static electricity. That's the little spark you can get if you rub your shoes on the carpet for long enough. Electromagnetic waves are a form of energy transferal, and some forms of electromagnetic waves include things like light or X-rays. Electrochemical potential is what we store up in batteries, and when we produce electricity with the battery, we say we're converting the electrochemical potential of the battery into electricity. This is not, however, how generators operate. Generators operate on electromagnetic induction, so D is the correct answer. Electromagnetic induction is something that allows us to turn mechanical energy into electrical energy. Question 13. Explain why a turbine is a necessary part of a generator. Why do we need something that spins? Well, think back to how we actually produce electricity in the first place. What we need to do is spin a magnet. So the turbine of a generator is required to spin the magnet inside the generator. And the magnet is what produces electricity by the process of electromagnetic induction, which requires it to spin. We can see just from the name, electromagnetic induction, that it has to do with both electricity and magnets. Question 14. Of a coal power plant and a nuclear power plant, which one uses less fuel? Explain why. Can you see what the answer will be? The nuclear power plant produces the same energy as a coal power plant using far less fuel. In fact, the energy stored up in a particular mass of uranium is about 1 million times greater than the energy stored in the same mass of coal. So uranium, a nuclear fuel, contains much more energy per kilogram than coal. Coal is a chemical fuel, but uranium is a nuclear fuel. Instead of using the chemical potential, it uses the nuclear potential in order to produce energy. The energy density of uranium is in fact over 1 million times greater than that of coal. That means that if we have a single gram of uranium, we need not 1,000 grams, but 1 million grams. That is a whole ton of coal in order to match the power of the single gram of uranium. Question 15. Compare nuclear power plants and coal power plants. When we have a question that starts with compare, it's a good idea to point out both the similarities and the differences between them. So coal power plants burn large amounts of coal for energy. Coal is very abundant in Australia. However, both mining and burning coal produces pollution. That might be ash, carbon dioxide, and sulfur dioxide. So these are some of the things that coal power plants are. Now we can compare it to nuclear power plants like this. We can use small uranium pellets for energy instead of large amounts of coal for energy. Uranium is also abundant in Australia, just like the fuel for coal power plants. And nuclear power plants are much cleaner than coal power plants. So that's one of the differences. However, the leftover radioactive waste is hard to dispose of. Coal power plants, of course, do not produce radioactive waste. Uranium mining produces pollution just like coal mining produces pollution. One of the similarities between the two types of generator is that they both produce heat, which is used to heat steam that turns a turbine. And that, of course, is what produces electricity. So we're at the end of the questions now, which means that we've finished the section. We've learned about various different forms of energy, like wind and water energy, nuclear energy, and coal energy, and talked about how they're used in generators in order to produce electricity.